Craig Trumpy with ATEC and AssetScan. Today I'm going to talk about extending reliability with IIoT with a video on a case study of an oven recirculation fan showing a lubrication fault. Today we'll be reviewing a predictive maintenance case history at a Midwest plastics plant. We'll be showing before and after data from the AssetScan bearing fault monitor. So let's get started. From the AssetScan.com website, you can go to the upper right hand corner and press the login button. Then, having username and password credentials, you can log into the AssetScan web portal. Selecting views and all assets, you can pull up the assets in your location. In this case, we have two. Today we're going to be focused on the case history around the Rotomold number 6 oven circulation fan. By expanding into here, you can see a picture or a small video of your installation. In this case, we see our sensor on the outboard bearing housing. This is a view of the inboard bearing. The rotor and or fan blades are on the other side of this wall. This is an overhung fan. To display the trend data for our measurements of interest, we can go to the right-hand side of the screen and select the trend icons for overall vibration and fault peak detection, which is our ultrasonic reading. Now we're looking at a 30-day trend with both overall vibration and fault peak detection. The overall vibration is the line in blue and is shown by the axis on the left-hand side of the chart. The green line is your fault peak detection or ultrasonic measurement, which is shown on the axis to the right, and that's a unit of Gs. Further distinction between these two measurements, the overall vibration is focused on 0 to 1000 Hertz and is fruitful for late stage failures of misalignment, imbalance, or looseness, whereas the ultrasonic measurement is focused above in the 1000 to 25,000 Hertz range and is focused on early stage bearing failure, lubrication, and cavitation. Moving to the alert window for ultrasonic, we're looking at 6, 12, and 18 Gs. These are set using the AssetScan artificial intelligence model for ultrasonic values. And on initial installation, you see the green line is above the 6G alert limit. And so we have a pre-existing fault condition. Other systems that use baseline techniques or machine learning and anomaly detection would not have seen this pre-existing condition. So using an AI model helps us see the pre-existing faults. So upon installation, there was an alert, and we have an AI model that then translates that alert into a prescriptive task. The first question many of our customers would ask is, I get an alert, now what? And so the AI model creates a prescriptive task which describes exactly what we want them to do. For a minor alert and ultrasonic, that task is to field inspect and lubricate. In our case, we generated this prescriptive task in an email to the production superintendent. He sent that email into his work order system, worked through their backlog, which is typically about 10 days. And as you see, 7 days later, completed the work. And you see the Gs in that green line reduced from 10 or 12 Gs to 2 to 3 Gs, well underneath the 6G limit. So what I want to do here, that kind of wraps up our case review for today. In review, we demonstrated the complete value chain for predictive maintenance by adding a sensor, generating an alert, generating a prescriptive task, and completion of work. This avoided a larger failure of permanent damage to the bearing, which avoided the increased shaft deflection and ultimately the fan rotor contacting the shroud, causing significant collateral damage. 2, we highlighted the difference between ultrasonic and vibration monitoring, both very useful, but both very different failure modes they're looking at. And 3, we demonstrated how easy it is to deploy an Internet of Things sensor with existing cellular and smartphone infrastructure to create instant value for your plant. If you have any questions, feel free to reach out to us at AssetScan.com. Thanks for joining us today.